Hello, 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 hello. Hello, great minds, hello, great minds, hello. Hello, hello, that one we did yesterday. Today we're gonna have a look at the right triangular prism. Uh-huh. And it looks like that. And on Monday we'll look at the cylinder. Uh-huh. Uh-huh, But let's have a look at that one. Hello, 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 hello. Grade nines. Okay, so today we're going to have a look at the surface area and the volume of a right triangular prism. Right, the surface area, again, it's the sum of all the areas of the faces that we can see over there. Okay, what is it made up out of? It's made up of two triangles. That's exactly the same area. And then you've got 1, 2, 3 rectangles. Okay, and so you only have to work out one triangle, you double that, and then you say plus the area of rectangle 1, plus the area of rectangle 2, plus the area of rectangle number 3. But we'll have a closer look at how it works in practice just now. And then also with the volume is half times base times height times the big height. So please remember that it's the, or you can remember it as the area of the base. So that thing, think of a Toblerone chocolate box, the base where it would stand on, the side that is doubled. So if it stands on the triangle, that would be its base. What is the area of the base? It's half times base times height times what it pops out with. So that big H, the capital H, that is the big height that it pops out with. So you find the area of the triangle times the height, the big height. Okay, but let's have a look. We're going to look at an example. Okay, there's that shape again. We've got those sides. The base there is 6. And we've got the height, the big capital height is 8. And then the two slanting sides, which makes it an isosceles triangle, is 5 and 5. So let's have a look. All right, so we've got two identical triangles. Can you already see that is that nice, perfect Pythagorean? Oh, Miss Baker says it's so nice. Pythagorean triple. I don't know, but it's a 3, 4, 5 triangle. Because if you take the base and you divide it by 2, it will give you 3 on each side. And always if you have a 3 and a 5, or if you have a 4 and a 5, or if you have a 3 and a 4, you must always think of that 3, 4, 5 triangle. So the height there we know is already 4. Okay, that's the front, and then that's the back. Okay, and I like to label all the big heights, slanting sides, just so that we can identify them easier when we're working out the area of the rectangles. So I label that one 8 and that one 5, just for ease of viewing or working it out. Okay, let's start at that rectangle number 1. Let's call it the front face. Okay, so for rectangle 1, can you see the area for that rectangle, length times breadth, will give you 8 times 5. That's correct. Then let's work out the back face. Let's call it the back face. The triangle there at the back, the rectangle there at the back. Let's call it rectangle number 2. And that is 8 times 5. Yes, because we said it's an isosceles triangle. Hey, so both of those, the legs of that triangle, the sides there is the same length, which is both 5 meters. Then the bottom. So let's have a look at the bottom. Let's call it the bottom face. That would be rectangle 3. So I just want to ask you, what would be the length and the breadth over there? Can you see, obviously, the length is going to be 8. And then can you see the breadth over there is going to be 6. Okay, so what I want to really emphasize here is if you get confused with all the different sides, if you're working out the 3 rectangles, you take that H, that big popping outside, which is 8 meters over here. And that gets multiplied with every side of the triangle. Can you see that? So you're going to say 8 times the 5. Another rectangle, 8 times the 5. Another rectangle, 8 times the 6. So that 8, he's the boss, and he communicates, or he talks to all 3 of those sides of the triangle, and that would make the area of the 3 rectangles. I hope that makes sense the way I explained it. So how would we work it out? So the 2 triangles is we have to acknowledge Pythagoras. So you're going to say the height is 4 because you take that base and you divide it by 2. So you're going to have 3 on each side. So you're working with a 3 at the bottom, and the height is asked, and the hypotenuse there is 5. So to get the height is equal to 5 squared minus that 3 squared will give you 16, and the square root of 16 is 4. Okay, I hope you can start identifying those triangles quickly so that you can quickly get to your answer. So the height there is 4 because of Pythagoras. And then you can say, all right, for a triangle, it's half times base times height. Half times the base is 3. 3 times the height is 4. 3 times 4 is 12. But because we have 2 identical triangles, we times that by 2. Okay, if you want to, you can pause the video and try and work it out to see whether you can also get 24 meters squared for both triangles. Otherwise, we can carry on. Then, for the 3 rectangles, I did it quite quickly because I think you are in grade 9 already. You can work it out quickly, or you can see where I'm going with all of this. So 8 times 5 is 40. Length times breadth, 8 times 5 for rectangle 2 is also 40, and 8 times 6 is 48 for rectangle 3. And you add all 3 rectangles together, and that gives you 128 meters squared. Then to get your total area, you add the triangles, you add the 3 rectangles all together, and you get 152 meters squared. Very important, surface area is meters. It's still the area that you're working out, just of all different faces of that shape, and it's 152 meters squared. Very easy, half times base times height. So it's the area of the base times that popping outside times that big H. So let's have a look. If we have all those measurements, we're going to find the area. Oh, okay, so sorry. First, we're going to find H, the height, and we said, like in the previous slide, that height, you can work it out. It's 4 meters because of Pythagoras. Then you work out the volume is half times base times height. That is the area of the base. That is the area of the triangle. And you times it by what it pops out with. You'll see on Monday when we work with the cylinder as well. You work out the area of the circle times what it pops out with. That gives you the volume. Okay, so half times base times height, half times 6 times 4, and times that 8 that it pops out with. And then you get your answer is 96 meters cubed. Please remember your units, people. You get marks deducted if your units aren't correct. Okay, so the volume, you always measure that in meters cubed. Then show your homework. But if you work quickly, then you can finish before the weekend. So your homework is exercise 21.1, only 3 little sums. I know it's not so little, but you can do it quickly. Page 284, number 2, A, E, and F. Oh, you must have a great day and keep safe, and we will see you or talk or speak again on Monday. Cheerio!